Assalamu alaikum wa rahmatullah. Good afternoon and welcome to all of our beloved viewers to the Voice of the Cape's Matric Revision session. Today, we have the honor of engaging with our sister Zainab, who is from Supreme Scholar, and she is going to facilitate today's session, and that is going to be dedicated to Physics Paper 1. As a reminder, on behalf of myself, Amir Adams on duty, we would like to thank our esteemed sponsor who made this year's Matric Revision sessions possible on behalf of the Voice of the Cape side as well. And that is, of course, none other than the Two Oceans Graduate Institute, an accredited institute that advocates for students to apply on their online private platform. And of course, where you'll be able to become a primary school or a high school teacher. And for more information, you may visit their website to find out further information pertaining to how you may excel in that regard. Without further ado, from our side here at the Voice of the Cape, we wish each and every one of the matriculant students who are currently embarking upon their trial examinations right now and who are eventually going to prepare for their NSC exams at the end of the year, that Allah Almighty grants you all the success as you prepare for your examinations. And our side, we will just merely try and assist all of the students who are writing for the various subjects to prepare adequately for you to take on your exams effectively, inshallah, as you commence and continue with your trial examination periods, or as we refer to it, your mock exams, and of course, prepare for your end of the year exams as well. For today, as I indicated, we have none other than our sister Zainab Afrika from Supreme Scholar will facilitate today's session, and that will be specifically dedicated to all of the physics students out there, where she will be giving over content for physics paper 1, dealing specifically with electrostatics. Without further ado, we immediately hand over to our sister Zainab to facilitate today's session. Bismillah.
Shukran, Brother Amir, for that introduction. A'udhu billahi minash shaitanir rajeem. Bismillahir rahmanir rahim. We begin in the name of Allah, the most merciful, the most gracious. And we make dua that Allah subhanahu wa ta'ala in this session, in the short session, that Allah subhanahu wa ta'ala opens our minds and He opens up our understanding so that we may able to take in the information today and process it and register it and understand it in order for us to, so that it can benefit us in our exams, inshallah. We say, Rabbi zidna ilma wa rasukna fahma. Okay, so today we are going to start on the second topic, which is electrostatics. If you recall, about 2 weeks and a half ago, we did impulse and momentum, and I hope all of you have benefited from those sessions. Please feel free to reach out to us if there's any questions you would like, or if there's any feedback. We are more than welcome to assist, inshallah. And so today we are doing electrostatics, and electrostatics is one of the biggest sections in our paper 1. And the reason why I wanted to do electrostatics before we go on to the other topics was because electrostatics deals with charge. It deals with positive and negative charges, right? And basically it is one of the fundamental concepts of physics. And so today we're going to be looking at the various concepts such as Coulomb's law. We are going to be looking at gravitational energy. We are going to be looking at point test charges, and we are going to be looking at electric fields. There is going to be 2 sets to this topic because it's such a big and it's such a broad topic. So today we are going to do some introduction, and we are going to do some basic understandings, terminologies, and calculations. And then for part 2, we are then going to dig deeper into the more complex nature of electrostatics. Okay, and so as I said, electrostatics deals with positive and negative charges, right? And so we can only experience a force, okay, when it spans over a distance. And so we're going to unpack that when we get to the part where we are going to discuss Coulomb's law. So for today, like I said, we are going to speak about electric forces, okay, and we are specifically going to deal with Coulomb's law. We are going to define it in terms of its theoretical understanding, and we are also going to define it in terms of its mathematical understanding. And then we're going to talk about electric fields. How do we define electric field? What is an electric field? How do we experience an electric field, or how is it presented in our physical understanding? And then we are also going to talk about electric field at a specific point. Okay, and then we're going to talk about lines, a little bit of, we're going to sort of branch off a little bit into magnetism, and then we're going to talk about the principle of superposition. Okay, so let's talk about charges. Okay, so like I said, electrostatics is basically the study of static positive or negative charges. Okay, so think about it like this. Sometimes when, let's say, you touch a door handle, you get this little bit of a shock, right? Or when you're walking on your socks and then you end up opening a door, you get like a shock through your body. That is due. That is due. Or that is because of electrostatics. I don't know if you ever did an experiment where it's called the balloon experiment, where you take the balloon, a ruler, and you charge it. So you will maybe rub it on your hair or on like a piece of, I'm wearing that kind of a jersey type of material, or anything that can induce a charge, right? And then you take that ruler and you bring it close to the balloon, and you will immediately see that the balloon gets immediately attracted to the ruler because you have charged the ruler, right? Remember, the ruler, before you rubbed it against your hair or before you rubbed it against a piece of cloth, it was neutral. Okay, and so when you did that exchange, you converted or you transferred charge. So this neutral thing then became negative. Okay, it became negative. It gained electrons, right? So when it gained electrons, it became negative, and then you put it close to something that is neutral, and obviously opposite forces attract, and that is why they could come together. There's something interesting that you could also do is you can charge a balloon. So you blow up a balloon. Don't waste water though. Don't waste your parents' a water bill. But you take a balloon and you induce a charge. So you take. It would be best to rub the balloon on your hair or something that has sort of a rough surface. And then you take that balloon and you open up the tap. You let the tap run. And if you bring the balloon close to the tap, you'll see that the water is going to deflect. And that's quite a very interesting experiment to do. And so you will see how electrostatics come into play in our daily lives. Okay, and then so we're going to basically speak about it. We can understand it. We're going to unpack why positive and negative charges attract and repel, and then we're going to basically demonstrate a method basically for determining whether an unknown charge is positive or negative, and that is going to come into the calculation. Okay, then we're going to also describe what it means when we say charge is conserved. Okay, we have conservation of energy, we have conservation of charge, and so we're going to basically unpack that. And like I said, we are going to just look at the applications of Coulomb's law and look at the applications of electric field as we go on. Okay, so as you can see here, we speak about the law of conservation of charge. Okay, so what is the law of conservation of charge? It says when two charged spheres are brought into contact with each other, electrons flow from the sphere with more electrons to the sphere with fewer electrons. Okay, so it's basically the laws of physics where we always go from a hot medium to a cold medium, from a high density to a low density, from fewer, okay, we're going from for more packed space to more less space, because generally the physical laws tell us that things want to choose the path of least resistance. That's why hot air rises, cold air will sink. Okay, we will always find an open space. We are always wanting to choose the path of least resistance. That's just how the physical laws sort of want to play. But we obviously have things that counteract that. Okay. And so we say that electrostatics is the study of stationary objects and their charges and what happens in their surrounding. Okay, it's created. Listen, this is very, very important. Charges. In order for you to create a charge, there must be a transfer of electrons. Okay, there has to be a transfer of electrons. So, like I said, with the example of the balloon and the water, when you charge the balloon, I'm transferring electrons from my hair, from my scarf, from my jersey that I'm wearing, and I'm inducing, and I'm basically going to move electrons from a positive to a negative side, or from neutral to positive, neutral to negative, and then I'm going to sort of bring it close to something that is not really charged, and then you will see the relationships between those things. We know by now, or we should know by now, that um, negative atoms are called electrons and positive atoms are called protons. Okay, we know that electrons are negatively charged and protons are positively charged. Okay, so that's the first thing. We spoke about electrons, protons, and charged objects. And charge, in order for something to be charged, there has to be a transfer of electrons. And we spoke about the conservation of charge. Okay, so I think this is very clear, very simple, and basically this is just a little bit of revision that we know that unlike charges, they they attract. They say opposites attract. I don't know how true this is for everybody, but um, that's basically just the law of physics, that opposites will attract. Okay, so we have when we have a magnet, the north and the south pole, and like charges they repel. Okay, and so no two things that are similar in nature or similar in character can occupy the same space because of the laws of physics and Newton's laws of gravity and all of those things, right? We have to have nature has to have this opposite imbalance, like I spoke about in the very beginning session when I spoke about um, in physics things have to there has to be a balance, okay, where there's day there's night. That's how Allah created us, right? That's how the universe was created, where there are polar opposites in order for things to be in equilibrium. Okay, otherwise if we have things that are the same, then we have sort of an imbalance. Okay, so it's important for us to understand this because it might be a basic concept to understand now, but for those of you inshallah who will make it to university and you're going to dig deeper into the subject, you will learn and come to understand that there's actually a deeper understanding to why things why this concept of opposites attract, and you learn those things in detail. Okay, then most important is our calculations. We cannot understand physics without a little bit of mathematics. Okay, so we talk about measuring charge. Okay, and one of the things that you will hear, or one of the things that will sort of be familiar, is or it will basically tie into, you will hear this concept again, is in electricity. Okay, and in electricity we talk about charge. Okay, charge is measured in coulombs. Okay, is measured in coulombs, and the basically the 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 the, the constant for charge is 6.25 times 10 to the power of 18. Okay, but a coulomb is basically defined as 1 amp per second. Okay, so in other words, we say that the amount of charge carried by 1 ampere in 1 second. That is how we define charge. Okay, and so Coulomb's law, when we talk about Coulomb's law is a measure of how strong the force is between these two charged objects. Okay, so I have charge one and charge two. I have these two charged objects, and then so Coulomb's law tells us how strong the force of attraction is between these two objects, and these two objects are going to exert a force on each other. Okay, like we said, it will either attract or it will repel. Okay, so that is something very important. When we have two charges coming together, and I want everybody to pay attention to this because this is very important. When we have two charges coming together, okay, it means that, and we're going to see it in in the calculation a bit later because it's something that usually tricks out a lot of students when we come to the calculation. Okay, so I have two charges coming together and they exchange charges, they either become negative or positive. They are going to move away with the same charge. They will have exactly the same amount of positive charge and the same amount of negative charge. Okay, so we say that these two charges are neutral. So I want you guys to keep this at the back of your mind because it's important to understand. These constants that are in front of you here are basically going to be given to you. Okay, like just like your periodic table, there are certain constants that are going to be given to you in order for you to answer these questions. And so these are not something that you have to memorize, but you must just look at the charge of an electron. It's extremely, and I can't infinitely small. 1 - 1.6 times 10 to the negative 19. That's 0,00000000000000001.16. Literally, it's very small. Remember, atoms are the building blocks of matter, right? Atoms are the fundamental blocks of that makes up the universe, that makes up us, that makes up all the things that you see in front of you. Okay, so it's extremely tiny. So when we talk about these charges, we are talking about millions and billions of them interacting. Okay, just for you to feel, that. Think about the current that flows through your body when you're walking with your socks on the floor, you're creating a charge on the floor, and what you end up touching the door. So what happens? You created a charge, which means that is going to induce a current, right? Because you were walking with your socks on the floor and your socks was rubbing against the floor, and that was causing friction, and so that travels up your body, and so when you open up the door or you touch someone, you feel like this prick, this major shock. Okay? That is thousands, billions of charges flowing through your body in order for it sort of to create that shock or to create that mini current. And so that is something that's very important to understand. Okay, so let's quickly talk about Coulomb's law, and then we're going to look at a calculation that involves Coulomb's law. Okay, so they are going to ask you, like I said at the beginning, you have 12 questions. You have impulse and momentum, you have Newton's laws, you have vertical projectile motion, you have electrostatics, you have all of these topics, and it's 12 questions, right? And each of these 12 questions contains a definition. For this section, the definition will always be state Coulomb's law. Okay, so let's go through it together and let's pick out the keywords that your examiner is going to be looking for when she wants to mark your exam. Coulomb's law is the electrostatic force of attraction or repulsion between two charged objects. Okay? And this is directly proportional to the product of its charges and inversely proportional to the square of the distance between the sentence. Okay, so let's look at the let's before we even actually read this whole long paragraph that really sort of kind of confuses us, because now we need to try and memorize word for word. Product. What is product? Product is times. So look, the electrostatic force, Fe, okay, between charges, whether attraction or repulsion, is directly proportional to the product of its charges. Charge is Q1 and Q2. Directly proportional to the product of its charges and inversely proportional to the square, number 2, square, and R stands for radius, distance between them. Okay? The formula in and of itself gives you the definition. Let's go through it again. State Coulomb's law in words, you look at your formula like the electrostatic force of attraction or repulsion, okay, between two charges is directly proportional. Directly proportional means they're on the same line. So 1 is equal to 1. Inversely proportional will be like the one is at the top, the one's at the bottom, right? So directly proportional to the product of its charges and inversely proportional to the square distance between their centers. Okay, and also please note that K is a constant. It is also given to you. It's not something that you're ever going to have to calculate. Okay, so please note that that is also given to you, like the charge of an electron and the charge of a proton. Okay, and so we say that Coulomb's law is the inverse square of, or similar to the law of gravitation. We're going to get to the law of gravitation. It is similar in that electrostatic forces can be attraction or repulsion. Okay, gravity is an attraction only. Electrostatic forces is strong and gravity is very weak. Okay, so that is just Coulomb's law. So let's move on and now sort of speak about electric fields. Okay, like we said, we're going to speak about Coulomb's law, and then we're going to speak about electric fields. Okay, so we're going to understand what electric fields are and how we identify them, and then I'm going to explain a little bit about point test charges, okay, and what kind of questions you will be asked about point test charges, okay. So how do we quantify, okay? How do we quantify, visualize, and understand electric charges? Okay, that is detected by the presence of an electric field. If I can identify an electric field, then I know that there are charges present. Without an electric field, you can't necessarily know that there's charges present. Or you can't necessarily know that the charges are interacting with each other because it might just be neutral. Okay? Electric fields are detected by the influence, attractive or repulsive forces. We spoke about that, and we call this a test charge. Okay? Electrical charged bodies can be created by physically rubbing electrons off one object onto another, for example. Okay, we spoke about all of that. So I just want to speak about this concept of this positive test charge. Okay, and what is this positive? Because those are also that is one of the definitions of a test charge. Okay, so when something experiences a force, okay, we define that as a positive test charge. Okay. You need to recall that you're going to have to, within your exams and in your question papers, they're going to ask you to basically draw a positive test charge. Okay, and so a positive test charge we draw with a circle and a positive sign, and we draw it just going up. We draw these lines going up, and we will go through some of these, or we will look at these pictures as we go on. Okay, then another thing that I also wanted to mention was with electric fields, right? Do not confuse the terminologies electric force and electric field. Those are two different formulas. Okay, so we have two types of electric fields. We have basically we have two types of fields that a charge can experience. It can experience electric fields and it can experience gravitational fields. Okay, now obviously gravitational field will be mass due to gravity, right? Mass due to gravity. And we spoke about this. Where did we see mass due to gravity? We saw it in impulse and momentum, right? We saw it in impulse and momentum. So in the same way, um, gravity is measured by dividing force acting on it by the mass quantity in kilograms. Okay, these are just technical equations that we need to understand in order for us to go through, or in order for us to understand how to solve the question. Okay. Now, I want us to look at this example, and it's important because it sort of gives us an introduction, or gives us a feel as to how the questions are going to be asked. Okay. So we have activity one. Activity one says this is a worked example, so we're going to work through it together. We're going to understand the question, and there are solutions attached, and we're going to go through the solutions, and we're going to see if our understanding makes sense. Okay. Feel free to sort of, once this is over, go through it again, pause. You can screenshot it if you would like it easier for your benefit. Okay. So it says two small identical metal spheres A and B carrying in a charge of -4 times 10 to the -12. Okay, and -3 times. So there's another thing I forgot to mention. I remember I said that charge is measured in coulombs. You get nano coulombs, you get pico coulombs, you got micro coulombs. Okay, we always work in nano coulombs. Okay, or we always work in nano coulombs. Okay, and so that we are saying, it says here these are mounted on an insulated stand as shown, and the distance between the centers of the spheres is 5 centimeters. Okay. Number one says calculate the magnitude and direction of the force that A exerts on B. Now you've heard this word magnitude already. This question is worth 6 marks. Okay. Calculate the magnitude and direction of the force that A exerts on B. Now let's look at how we solve this step by step. Okay. First of all, they said calculate the magnitude of the force, which means you use Coulomb's laws. Why? Because if you look at what you were given, okay, you were given sufficient information to use in order to plug into the equation. Okay, you were given the distance. Okay, you have K, which is a constant. Okay, and you were given the charges of both. You were given basically the coulombs of both forces, okay, of both charges. So you obviously you calculate the electrostatic force. That is the magnitude, okay? That is the magnitude, because they're asking you for magnitude and they're asking you for direction. So this, all in all, is worth 6 marks, okay? This, all in all, is worth 6 marks. Why? Because you first needed to identify that this is the formula you need to use, okay? The second thing you needed to identify was so they don't tell you, so look here, they don't tell you that it needs to be, this 5 centimeters needs to be in meters, but we know that SI units needs to always has to be converted to meters. So there's an additional mark for converting this 5 centimeters to meters, okay? And now we see that this is negative, but over here, this is positive. Why is that the case? Why is that the case? Why couldn't it be? Because they gave us both charges. They say it's -4 times 10 to the -12 picocoulombs, which is -12, and this is -3. But if you look at the calculation, they left out the negative. So only when it comes to this calculation, Q1, you always carry Q1 with its original sign. Always. Q2 is not necessarily, you don't have to carry it with the charge. Okay? Q2, you don't have, and it's because of the mathematical setup of this equation. Okay? But if you want to be on the safe side, you can write both signs. It doesn't really matter. Okay, so that wasn't a mistake. That was noted and it is there. Whether you put the sign in for the second charge or not, that's okay, because here we're talking about two test charges. We are talking Q1 relative to Q2, but you can only do it for this equation. Other than that, you cannot. Okay, you must make sure that you carry the signs within the equation. Okay, and so this you all plug into your calculator, and you should get an answer of negative 4.3 times 10 to the negative 11 newtons. But they ask for magnitude and direction. Okay, they ask for magnitude and direction, and here it says this is a force of attraction. It's a force of attraction. Why is the direction a direction force of attraction? Why would it be a force of attraction? Because the sign tells you. Okay, negative charges they attract. Okay, positive charges they usually repel. So if that was a positive, if that number was positive, it means that these two charges were drifting apart. Okay. And so another thing that I also wanted to mention was when we go, so we're just going to take a little bit of a step back before I get to the exam question. I wanted to just explain the concept of the electric field. When we talk about the electric field, remember the electric field is for a positive, what a positive charge is experiencing. Okay, what a positive charge is experiencing. So it usually is the case that we don't always write, or we don't always have to have two charges. We can work with one charge. But this is something I also wanted to mention, and this is something I feel like is extremely important. Is that when you're working with electric fields, the hint, okay, the hint to working with electric fields, and we're gonna go through a question, is the charge of an electron or charge of a proton. So you might sit in the exam and they ask you to calculate the electric field, but you don't have any charge. Okay, you don't have C. So what you're gonna do? You do have it, okay? Because it's the electrostatic force experienced by a positive test charge, which is um one atom. Okay, so if you sit in the exam, you're like, but I'm missing something. I need to only have one variable that's unknown, but I have two variables that's unknown. The other variable is going to come from your constant table. This is given to you. 1 coulomb is equal to 6.25 times 10 to the 18 electrons. Okay, so please keep this in mind. It's very important because they're not always going to spoon feed you, or they're not always going to give you all the information. Okay, and so it's important for you to derive the information from the table that they're giving you. And so we're going to go through our final example that we're going to go through before we end off the session is an exam question. Okay. So this is just the first part of the exam question. We still need to unpack a lot more when it comes to electrostatics, and we're going to dive deeper into it in our next session. So let's go through our final question for this evening. Okay, it says the diagram below shows a metal sphere of X negligible mass on an insulated stand in a vacuum. Okay. 3.125 times 10 to the power of 10 electrons have been removed from the sphere. Draw the electric field pattern associated with sphere X, and this is exactly what I was coming to, okay? Because it's at this point in the year, for us to go over all the theory with the limited time we have is not possible, okay? So as we are doing the questions, we are relating back to the theory that we briefly mentioned in the beginning. So they want us to draw an electric field pattern associated with sphere X. Look at where sphere X is situated. It says 3.125 times 10 to the power of 10 electrons have been removed. Okay? So now it says draw the electric field pattern associated with sphere X. Is sphere X positive or negative? I've obviously gone through it, but just think, take a wild guess before we actually look at the answer. Okay? So number 1.1 says we need to draw the electric field pattern. Then it says describe an electric field. What is an electric field? What is an electric field? We spoke about it and I mentioned it earlier. And then for 1.3, they want us to calculate the net charge on the sphere. Calculate the net charge on the sphere. So we're looking for charge. So remember, I just went back to it now. And then they want us to calculate the electric field. So this part has got to do, so we did one where we calculate the force, the normal standard equation, F is equal to K multiplied by Q1 multiplied by Q2 over R squared, standard procedure. Okay, here we are talking about electric fields. Okay, so let's now answer these questions together. When they ask us to draw the electric field, remember I kept going back to positive test charge, positive test charge, positive test charge. Remember? So whenever you are unsure, because you were not given, like in the previous question, you are not given this one is negative, this one is positive, this one is negative, and this one is negative. Because if had you been given that, you would know how to draw the electric field, because it means that the middle part is being repelled by both of these charges. But we do not know what the charge is. We don't know if this side is positive and the side is negative, or we don't know if both of them are negative or both of them are positive. We don't know that, okay? And so that the next option, once you've eliminated that, the next best possible answer was to say, okay, this is a positive discharge because it's going to experience a force within the electric field. Okay, and then we need to describe an electric field. It's a region in space in which an electric charge experiences a force. Remember, I said it at the beginning. We can go back to the slides again. I said in the beginning, in order for you to detect and whether there is a charge, there has to be an electric field. Okay, there has to be an electric field. So an electric field is a region in space where we can experience a charge, we can experience a charge. Okay, and how do we know what is the so this is for that's one mark. For the next mark, you need to explain to them how would we detect that, okay, and how would we know what the direction of the electric field is. And so the direction of the electric field at a point is the direction that a positive test charge would move if it is placed at that point. Okay, so that the positive test charge is basically our baseline, our variable that we compare everything to. Okay, and then the third question asked us calculate the net charge on the sphere. So charge is equal to N multiplied by E. They gave us the number of electrons. Okay, and this, remember, I spoke about it again. I was like, remember, if you don't know what, you don't have enough information, go back to your constant table. There's constants that you can use. N is basically just the number of electrons that they were speaking about, multiplied by E, which is a constant 1.6 times 10 to the negative 19. Okay, this E is a constant. N stands for number of electrons. They told us that 3,125 times 10 to the power of 10 was removed. So that's the number of electrons, okay? All of these formulas will be given to you. The formulas are your guide to answering the question, okay? And then calculate the electric field at point P. Remember, I also said before I came to this question, we only sometimes need one charge. Okay, at point P, that's only one charge. So we're trying to find what the electric field is. So it's going to be K, which is a constant, Q, okay, because we've just calculated the charge. So see how these questions are related to each other. Q was what we just calculated, okay, over R squared. We had the distance, and that must give you an answer of 17.31 newtons per coulomb away from the charge. Okay, and so I hope that this session sort of gave you a little bit of insight. As these are typical exam questions. It seems difficult on the surface, but if you dig deeper and you understand the theory that goes with these with these applications, then it becomes a lot more easier. It becomes a lot more doable. And I want to encourage you guys to practice, do as much examples as you can. And definitely your hard work will definitely pay off, inshallah. So I hope that you have now a little bit better understanding of how we solve for Coulomb's laws, how we understand charges. Okay, these are the basic examples, but what if you have three charges or you have four charges? Then you must end up doing Pythagoras and all of those things, and we're going to come to those things in our next section, inshallah. But I do hope that this was beneficial to you, and I do hope that you've learned a lot. Shukran and jazakallahu khair.
MashaAllah, we say shukran, jazakallah khair, and terima kasih to our sister Zainab Afrika from Supreme Scholar who so beautifully facilitated today's session that was dedicated to all of our physics students out there. Of course, physics a very difficult subject, but as you could see, alhamdulillah, in Zainab's presentation, if you practice and implement all the advices and discourse of Zainab, then inshallah you will be able to succeed in your examinations. And of course, as a reminder, this is the Voice of the Cape's annual Matric revision program that is proudly being sponsored by the Two Oceans Graduate Institute, which is an accredited online platform where you can become a primary school or a high school teacher by studying in the privacy of your own homes. And if you'd like to find out more information, you may go onto their website www.togi.ac.za, or you may call them on 021 829 7015. And of course, that is the details pertaining to our official sponsor for this year's Matric Revision Program, that being the Two Oceans Graduate Institute. Once again, on behalf of our side here at the Voice of the Cape, we'd like to say shukran and thank you very much to all of you for basically viewing today's session, the Matric Revision session. It was dedicated to all of our matriculant students who are writing physics. And as I always remind you in conclusion, all of our beloved viewers, please ensure that you forward and share this link of the VOC's Facebook page and the VOC's YouTube page, and all of the sessions that we are conducting matric revision wise, to all of the matriculant students out there who are preparing for the upcoming examinations, inshallah. From our side, we'd like to once again thank our sister Zainab and wish her everything of the very best, and we hope that all of the physics students out there in the community will benefit from this as they prepare further for the trial examinations and the NEC examinations at the end of the year. And from our side, we'd like to thank you all for basically viewing today's sessions, inshallah. There will definitely be more sessions forthcoming as the days and weeks go ahead, and we wish everyone all of the very best as you prepare for your exams, inshallah. From our side, we say shukran, jazakallah khair, and bayt ramakasi. Wassalamu alaikum wa rahmatullah.